So I was asked about item 2.6 on project 2. And here is the model section. And you're being asked, define the model type algebraically in point slope form. So for one, remember point slope form is, the y equal mx plus b. And so for us, we're using, what the heck are we using in this one? This is the Dale and IMR. So, the IMR is the X and the Dale is the Y. And, oh wait, and I messed up. So sorry if you were yelling at me. Point slope form, I said. So point slope form, y equals m times x minus some x1 or x0 plus y1, where the point then, so the slope is m and the point is x1, y1. Now, in this case, the idea was, right, we're building on project 1. And so remember in project 1, you sort of had a fixed point to work with. You had 0, 0, and you had your data out here, and you wanted to find that slope that fit that beautifully. Well, when you go to any general line and you do that sort of thing, well, it can get kind of hard because you're trying to, if you think of, say, the y-intercept and the slope, you might say, well, I think the y-intercept's about there, and then oh wait, no, that's not quite right, but maybe I needed a slope to go up a little more, and and you start drawing that one, and oh well, that looks pretty good, but you're kind of dealing with two things. But what we point out in the project is actually, if you're if you've got these data out here, then you can kind of reduce it to the same problem we had in project 1, is that, here's the average for X, here's the average for Y, it'd be somewhere in there. And we know that the best possible line you could pick is going to go through that point. And so now, it's a matter of, oh yeah, that slope's not any good. That slope looks much better. So there's the line I want. And so in a point slope form, you got y equals m times x minus x bar plus y bar. And see, so that point just by taking your averages of your data, your x and y data. And so now, you can get on something like Desmos and graphically just kind of mess with that slope till you decide you find a slope that works best for that. Okay, so that's that first part of the point slope form. And, it says discuss using the X bar and Y bar to help us. Well, see, that's how it helps us. It anchors us so that all we really have to concentrate on is that slope. We're just kind of picking these different possible lines, and, and probably that was the one to pick, or somewhere right in there. And that makes my job much easier than having to change both, say, the y-intercept and the slope. Okay, because if I'm trying to change two things, well, changing one could mess up the other, that kind of thing. So that's, that's how knowing that my answer goes through those averages, it helps me just really quickly eyeball what I want there. And again, this is our algebraic model. Now you need to define, there's our algebraic model, but that's where, x equals IMR, and y equals Dale, or D-A-L-E. You know, if I don't mention that, um, then who knows what those mean, and so it sort of ceases to be my model anymore, because, well, is X the Dale data or the IMR data, and so forth. So you know, I've got that kind of thing. And so, you know, as far as then the screenshots, well, we just want to see that you used your spreadsheet to find the averages of these. You know, that's all we're doing with the, you know, item 2.6b, where it says include a screenshot. You know, we just want to see that you were able to calculate those averages and didn't phone a friend or something like that to get it. And then give your answer for the best slope. Well, you know, I don't remember what that slope is, and actually, what I do remember for C is that my data, my data actually are going down like that, and so the average, you know, is somewhere in there, and I found a slope like that. So, you know, my best answer is going to be negative something. So, you know, let's just say it was -2, you know, x minus whatever x bar turned out, you know, so maybe the average of the IMR was 5 and the average of the Dale was 12 or something like that. Okay, then there is my model that I came up with, and my best guess of the slope. And like I say, I don't remember what it is right off, and even if I did, I wouldn't tell you. That's for you to figure out. But I will say it should be negative, because things are decreasing as we move to the right. And then give a couple of examples. Well, so suppose that's my model, then uh, you know, if IMR was equal to 3, then according to this model, I would get Dale equal to -2 times 3 minus 5 plus 12. And so that would be -2 times -2 plus 12. And so that is 4 plus 12, or 16. So there's my example 1. And then another example, you know, maybe I have an IMR equal to 5, in which case Dale would be -2 times 5 minus 5 plus 12. Well, 5 minus 5 is 0, so I just get 12. And so there's a couple of examples of using this, is that if, you know, if I knew, you know, if I had a published report that, you know, that a given country had an IMR 3, I'd say, oh, it's a Dale, probably ought to be somewhere around 16. And similarly, you know, if I got a published report that its IMR was around 5, you know, then its Dale would be around 12. Okay, so that's, you know, kind of item 2.6. My idea for this video was not to just kind of go through and list what answer you should give, but to kind of give you that background so you can try to put it in your words. But hopefully that can help you out with item 2.6.